Hello, my name is David Burke, and today we will be exploring content-based image retrieval, CBIR for short. So you may encounter the problem, how do I find an image in my database? A stock photo company may have this issue. They often have tens of thousands of images. Searching by name may help, but that may not be enough. Sometimes a user may want an image with a certain tone. Searching for a dark image may not produce the desired results, or the user may be searching for an image that is similar to something that they found previously. How can you help the user in the cases where searching by image name isn't feasible? For this purpose, content-based image retrieval can help. The basic premise is that an image is found by using features of image. This is opposed to searching by metadata, such as the name of an image. The content-based image retrieval we will discuss today uses query images. A query image is an image that is selected as a base to compare to the other images in the database. Then, by using visual features of the images are sorted. Content-based image retrieval queries can find images that other forms cannot find. Simply searching through metadata may not get the image you desire. A search for a night sky may provide a skyline of a city at night. However, by using something close to what you desire as a query, you can quickly find similar images, and those might be much closer to what you want to find. This is faster than sifting through potentially thousands of images. In this example, we have a query image on the left. This is an image of the Oregon wildfire in 2020. By using a content-based image retrieval software, we can find visually similar images. On the right, you can see there are two images that were returned by Google, which uses content-based image retrieval. What does content-based image retrieval achieve? Quite simply, it is a method to find an image within a database. It searches and sorts through the database based on the query image that you have selected. The search can be for multiple image features. Then it ranks them based on the image features that you chose and how close they are to those image features. Finally, it returns images that are similar to the query image based on the features that were chosen to be searched. What are image features? Image features are types of information that can be gathered from an image. This includes, but is not limited to, properties such as color and texture. Depending on what features are gathered and what metrics are used, the return images can vary. To the software, an image feature is data that can be compared to other images. Image features are gathered from the images and then compared to see how similar they are. This is how the images are sorted. As an example, if a database of images have their color as an image feature that is used as a comparison, then the returned images will be similar in color. A content-based image retrieval query can have as many or as few image features as required by a client. Here we have some image feature examples. On the left, we have color. The color of the image that we searched was blue, and an example image was found below of blue roses. In the middle, we have an example of a CBIR using texture as the base. You can see that in the image of the rocks that there is a rough texture. Because the texture is rough, the CBIR found an image with a similar level of roughness in the texture. And on the right, you can see shape. In the query image, we have a round table. As such, it searched for objects that also have round profiles. The object that it found was basketballs. So, how does content-based image retrieval sort images? Image features are ranked by any number of metrics. Color can be one such metric. Of course, the metrics are the image features of the images. Each image's data is compiled. In the case of color, the color data is gathered into a histogram. This data is then compared. Are the numbers equal or large in difference? The more equal the numbers are, the more similar the image is. In contrast, the further the numbers are, the less similar the image is. The images are then scored based on how similar they were. More similar images score higher, while less similar images score lower. The scored images are then presented back to the user. The returned images will be similar to the original image in one metric or another. Sorting through texture could return images that are rough, but it may not necessarily match in terms of color or shape. Here is a content-based image retrieval sort ranking example, a sample of how sorting would look. The selected query image is on the left. Here you can see that it features islands in the background and fish underwater. The query returned the first image, which features fish that look visually similar to the fish in the query image, so it was ranked first, along with having blue water. The second image features an island in the middle. Although the islands are not as large, the islands still look visually similar in terms of the composition of the shot and the colors. The final ranked image is of a turtle, which ranked the lowest because the composition isn't as close as the other two images. How would I implement a query by example content-based image retrieval? Implementing a content-based image retrieval system with query by example is a four-step process. First, you must select an image database that you wish to process. Then, you must choose which visual features we would like to extract. Then, you must compare the query image to each image in the database and use the visual feature as a metric to determine how similar they are. Finally, you must then order these queries and present them to the user. Now that we have explained how to do content-based image retrieval and what it is, we will now present the code that I have. To start, we must first create the database. So here you can see I have chosen my import path of the database, going through Spring 21, CSI 453, midterm data import, finding the folder that I need the database from. We then construct a file list, getting all of the images out of that folder by using the import path. Then we set the size of the data to the length of the file list. Because we filter for only JPEG images from the import path, Even if there are other files, the dataset size will only include the images in that folder. Next, we create an empty matrix of the same size as the dataset, and then include a second row or columns that will contain the data for each image. Next, we create a loop that goes from 1 to the dataset size. We then read from that folder the index's name. For instance, the first image, for the first run of the loop, it will read import path, which is the location of the folder, and then get the first index in that folder from the file list. And then that will be what we read. We then take that and get the 6-bit color code using the RGB26CC fast. And then we store that in the empty database we just created and save it. Once we have created the database, we can begin the content-based image retrieval. Similarly, we have the same import path so that we may get the images as well, but we will be using it differently. This will actually get our query image. What this stores is the image that we select using the UI getFile function from that folder, and shows us only the JPEGs. Once we have selected an image and set that as the value of file name, we store that as IMQ or image query using the IMRead function, getting from the original import path and then the name of the file that we picked and store it here. Then we take that image and we convert it into a 6-bit color code like we have in the database. Then we get the histogram count of that 6-bit color code in order to put it in the same format that we have in the database. Next, we load in the database so that we may start comparing our image to all of the images in the database. Then we create our matrix to store all of the queries. Finally, we loop through the database with this for loop. We will then find the distance by first getting the index of what we want to compare as P. This is the index of the image we want to compare. Then we get the distance between them using this function. We store the image we're comparing as Q, and we store the query image as Q, and we store the image we want to compare as P, and then we use the getDistance function to get the Euclidean distance between the images. Finally, we sort them by index so that the first return image is the most similar. Then we take the top 20 indexes of that so that we don't have a list of 100. Finally, we take the file list, which is same as create database, and we use that in order to put it into the figure. So once we have created the figure, we show the original query image as the first image in the figure. Then we have a loop that will go through all of the top 20 images and store them as IMT by reading it from the file list that we've created. Finally, we use subplot to place those images onto the figure. And if we run, and we select an image, and we got the top 20 visually similar images. Thank you.